The last title today is towards an it's behind me. I don't know why I'm reading out. Towards an ecological mathematics, new correspondence with the natural world. Siddharth, the floor is yours.
Thank you, Karen. For those joining online, we'd like you to feel as though you're here in person. So if there are any issues like with sound or anything, then just type something in the Q&A, try to address it. We're also hoping to record the talk, so for those who don't want to be recorded, if you could make sure your cameras are turned off, that would be great. So this talk is going to be about the relationship between maths and the natural world more generally. I'll aim to speak for about 40 minutes so that we have plenty of time for questions. The one thing I ask is that you try to suspend your existing ideas of what maths is, keep an open mind to what it could be. Before I begin, I'd just like to thank the Renew Secretariat for helping to organise this talk, and also to my friends and family and teachers for helping bring this work into being. Okay, thanks, Simon. So maths is a field of knowledge that's usually understood to study patterns, structures, quantities. Historically, maths has long developed in close reciprocity with physics. Figures such as Emmy Noether and David Hilbert, who played a leading role in one discipline, often did so in the other. As such, many areas of maths like Riemannian geometry and Newtonian mechanics provide effective and bespoke tools for codifying the experimental and theoretical findings of the physical sciences. Now, motivated by this ability of maths to elegantly model phenomena at scales from the subatomic to the cosmic, as Fikret Burks writes in his landmark book, Sacred Ecology, an overwhelmingly large part of ecology tries to adhere to the tenets of conventional science. Now, in contrast with the historical interchange between maths and physics, the relationship with ecology has been mostly one way. Many advances in the mathematical formulation of ecological theory come from mathematicians with backgrounds in the physical sciences. So Vito Volterra, Vladimir Kostitsyn, Alfred Lotka in the early 1900s began to apply their methods of differential equations from physics and chemistry to study questions of biological population dynamics. This was then furthered by mathematician Robert MacArthur and physicist Robert May, who became key figures in ecology later in the 20th century, and who, in the words of Robert May, rephrased ecology in the idiom of theoretical physics. As a result, mathematical methods have been transplanted from the physical sciences with little conceptual or philosophical modification for an ecological context. Ecology is often treated as the inert substrate to be inoculated by the clarifying principles of maths. But this hierarchy of disciplines, which places mathematical knowledge on a pedestal, has the following consequence. Rather than growing new mathematical theories from ecological concepts, instead, only those ecological phenomena which are amenable to existing methods of quantification get studied. An example of this in modern conservation science arises in the subject of animal movement. So one of the most popular approaches to mapping patterns of animal movement and landscape connectivity is the software CircuitScape, which is used both in theoretical research and by governments and land managers worldwide in conservation decision-making. So CircuitScape draws on the physical theory of electrical circuits to model animal movement in a landscape as an electrical current flowing through a giant circuit. Now, as is typical of movement models in ecology, authors characterize the creature as a random walking automaton, lacking purpose or agency, which moves through the landscape according to a cost-benefit logic of resource extraction, the animal economicus. The authors of CircuitScape conclude, we find that the method objectively identifies important elements similar to those identified by the human eye, replicating expert opinion, but removing potential sources of bias. Now, electricity as methodology is one thing, but I think this quote is interesting because just like putting on red-tinted glasses and concluding that the world is red, it suggests a perceptual conflation between model and reality, foregrounding and affirming that which fits the lineaments of physics, and implicitly but actively brushing aside that which is difficult to measure with existing mathematical methods. As a mathematician undertaking environmental research in Britain, I'd initially taken it as a given that the natural world and the social world are separate, because you can see it in the names of academic disciplines. Natural scientists study the laws of nature, social scientists study the human world. But I did start to wonder, when studying animal movement behavior in ecology, was I really learning about how animals interact with their environment? Or was this just a projection of human behavior in economics? What social, cultural, psychological threads are hidden within mathematical models behind the language of objectivity and removing bias? Here's a passage concerning the stipulated movement rules by which animal populations cooperate from a chapter in the seminal textbook Theoretical Ecology, authored by two highly influential mathematical biologists. They speak of 5 different kinds of mechanism whereby cooperative behavior may be maintained in a population, despite the inherent difficulty that cheats may prosper by enjoying the benefits of cooperation without paying the associated costs. Now, one of these 5 so-called mechanisms is based off the prisoner's dilemma, in which if both defect, they receive the punishment P. If one cooperates and the other defects, then the cooperator receives the sucker's payoff S, while the defector receives the temptation T. They then formulate this mathematically, and through the logic of maths, deduce that cheats receive better payoffs than cooperators. Now, just from my own experience, if I behave extractively and I obtain something which harms another, then my gain is ephemeral, because whether or not I'm conscious of it, this action leaves an imprint in my mind that sows seeds of separation and fear that other people will treat me the way that I treated this person. And ultimately, this causes me more overall harm than benefit. This is not to say that the electrical or cost benefit or cheat and sucker frameworks are somehow wrong or bad, but rather what I think is surprising is how one very particular set of ideas has come to dominate the way things get quantified in ecology, without an acknowledgement that other ways of doing maths in relation with the modern human world might be possible. So let's take a step back from the use of maths in ecology and have a look at maths itself. In recent decades, disciplines such as geography and anthropology have examined the ways in which their methods and theories are profoundly shaped by how one conceives of the natural world and understands the human place within it. As Zoe Todd, Vanessa Watts, Kim Tallbear, Robin Wall Kimmerer, and others write, these contemporary academic terms not just resonate with, but actually draw directly from knowledge's long practice beyond the academy. In contrast, maths in the Euro-American cultural world is typically presented and taught as a system of timeless truths, ahistorical, external to and detached from the conditions and contingencies of human life. However, recent work in the history of maths and in ethnomathematics suggests instead that the direction along which mathematical ideas develop is inseparable from the emphases and the priorities of the encompassing society in which human mathematicians live and work. For example, as Marcia Asher writes in her book on ethnomathematics, the complex encoding of histories, songs, and government policy in the not theoretic Kipu of the Tuantinsuyu or Inca reflects their value of bureaucracy and the orderly processing of multiple kinds of data. as did the navigational practices of the Polynesian wayfinders inform the star compass of their geometric models. Just so, biopolitics and the desire to govern and classify human populations led directly to concepts and theories of statistics, and concerns with efficient material distribution in the 20th century guided the rise of optimization and linear programming. Historically speaking, mathematical notions that we take for granted today, like negative numbers or the equal sign, weren't even used before the 16th century, even though maths has been going on for millennia. And even the notion that counting with an arithmetic base of 10 is somehow natural because having 10, or most of us having 10 fingers and toes, that falters over the example of the Yuki in present-day California, who count with a numerical base of 8 for precisely the same reason, except they count the spaces between the fingers rather than the fingers themselves. The Yuki suffered a horrific genocide in the mid-19th century, and I wish to name them here so that their approach to maths is not forgotten. Now, as anthropologist Marilyn Strathern writes, the nice thing about culture is that everyone has it. Indeed, there is no objective way to linearly grade these different mathematical manifestations across cultures on a scale from simple to sophisticated, because such a metric would always be biased by a preference in this society for abstraction and theoretical generalization. Now, as with much of anthropology, this is not just like examples of other cultures over there, but also it's an invitation to reflect on how things that one may take as, oh, this is a fact of life, or this is the way things are, might actually be historically and culturally quite specific, and therefore open to change. I'm not saying that maths is like entirely socially constructed in binary opposition to being a truth of nature, but simply I think ethnomathematics highlights how there is no universal path along which mathematical ideas develop. So, if the theories and concepts of maths are not immutable, if they're shaped by the zeitgeist, if they respond to the needs of the time, then I think that the ecological crisis of the present day is at least an invitation to examine whether the worldviews and the assumptions guiding the use of mathematical models in ecology could be made more explicit and perhaps revised for maths to enter into a deeper and richer role in environmental work at this time. A place to begin this inquiry would be to look at one of the fundamental tenets of maths that's usually considered irreconcilable with the living, breathing richness of the natural world. Abstraction. The literal root of this word means to pull away. It appears all the time in everyday life, but it's particularly central in maths. Abstraction is both what lends maths its remarkable ability to universally approximate patterns in physical phenomena. And it's also what detaches it from being able to attend to the uniqueness of any one ecological system. Perhaps surprisingly, abstractions always carry with them an imprint of the worldview from which they spring. For example, the philosophy of René Descartes in the 17th century, which has been foundational in the evolution of academic maths and science. Well, in that he argues that animals are machines that lack intelligence or creativity. And I think this bears striking resemblance to the widespread assumption in ecological science that animal behavior and their spatial distributions can be known and modeled by mechanical mathematical laws. And we'll return to that point in a moment in a discussion on language, but for now, although the mechanistic approach has proven to be a highly valuable methodology, as David Abram writes in The Spell of the Sensuous, by relying only on such models as the primary means of knowing the world, sensory connection with the living landscape becomes mistrusted. And this serves to isolate oneself from those phenomena which are not so easily captured by the usual techniques of scientific analysis. following from Galileo's assertion that the book of nature is comprehensible only in the language of maths, it seems that maths has positioned itself as the guardian of the universal truths of the natural world, and anything which doesn't conform to its abstract ideals is spoken of just as noise or error or random variation. Now, some mathematicians, such as Peter Challoner and others in the X1 collective, are drawing back into scientific discourse those things which have been discarded under the rubric of uncertainty, and instead looking at them as the productive space of possibility. Moreover, just as I forget the magic of the stars until walking along Pendennis Point under a clear night sky, and just as I cannot know what an apple really tastes like until I bite into one and chew, so too do manifold depths of the non-human other remain hidden to me until I bring my perceptual experience and my bodily intelligence to the foreground of my attention. Finding a way of doing maths in ecology which doesn't homogenize human difference and take the body for granted is going to have to rethink abstraction. We can start by recalling that the earlier examples in ethnomathematics suggest that abstraction is not unique to any one culture. It's to be found and valued by human societies throughout the world. Here's a painting by Haida and Tlingit artist Robert Davidson. It's undoubtedly abstract, but as I learned from speaking with Tlingit artist Harmony Hoss during a conversation we had in the Pacific Northwest, the use of abstraction here is not to effect a removal from the fleshy, earthly world, but rather to bring it to life by drawing forth and making visible particular qualities of lived experience. In this case, how animals can shapeshift and have a fluidity of form in our visual perception. In a similar vein, geographer Derek McCormack draws on the mathematician and philosopher Alfred North Whitehead to remark how certain kinds of abstraction have the potential to make us more rather than less sensitive to the world in ways that others do not. So how can we use abstraction in maths, given that it's so fundamental to maths? How can we use abstraction as a way to enliven and elicit rather than to stifle or eclipse the subtlety and complexity of the more than human world? I'd like to suggest 3 ways to approach this. Seminal book by cognitive scientists George Lakoff and Rafael Nunez on maths and the embodied mind presents an investigation into the origin and development of mathematical concepts. The authors draw on decades of empirical research in cognitive science to argue with lucid precision that mathematical ideas may not be immaterial, but may instead arise from our direct bodily experience of the world. Briefly speaking, the authors draw on the theory of conceptual metaphor to demonstrate how arithmetic laws like 2 plus 1 is the same as 1 plus 2 apply perfectly to counting physical objects, precisely because how we conceptualize those laws arises from our lived experience handling physical objects. The mathematical notion of infinity works really well for modeling indefinite processes, precisely because how we conceptualize the mathematical notion of infinity arises from our lived experience of indefinite processes. Now, the main point here is that if the way we comprehend mathematical ideas is a derivative and a refinement of how we conceptualize our lived experience of the world more generally, then I think this implies a heuristic for mathematical modeling in ecology, which moves beyond application to attunement. Because if the application of maths to ecology presumes at the outset that these 2 domains are separate, then attunement is listening to how each already emerges in the other. Rather than asking what mathematical ideas apply to this ecological phenomenon, instead we could ask, this ecological phenomenon provides the conceptual ground for which mathematical ideas. In practice, this means a shift in priority for the modeler. For example, I'm presently writing a mathematical model on spatial planning in nature recovery with Kevin, David Baker, and Ilya McLean. And rather than being wedded to my favorite mathematical theory and insisting on molding ecologies in their image, and instead committing to starting with ecological concepts and listening to what mathematical ideas they speak, even if those ideas are uncomfortable and unfamiliar. This has made the modeling process surprisingly lucid and straightforward in comparison to my first attempts in mathematical ecology. The renowned ecologists Herbert Andrew Worther and Charles Birch note that the experiments that a scientist may devise, and therefore the facts they may discover, as well as the explanations that they offer for them, depend on how they conceive of nature. I think this is especially true because how one conceives of the natural world and how one perceives it intertwine. Questions and hypotheses elicit answers in their likeness because the richness of language, thought, and experience all shape each other. But if I'm not watchful, continually speaking of ecologies as cost-benefit machines for the sake of quantifying them slowly begins to truncate my connection with the living landscape. As my scientific language becomes impoverished, so too does the scope of how I can think through environmental questions. Moreover, the expressive presences of wind and water, hawk and hawthorn, themselves withdraw from my perception, their life worlds muted, stripped of colour, by words which flatten their depth and deny their mystery. Indeed, I think it's only from this way of seeing the world that a mathematician may assert, as I quote from this paper on modelling insect population control, some ecologists and pest managers may argue that these mathematical ideas are not useful because biological systems are different from mechanical systems. Yet biological systems are just another dynamical system. They both have finite life expectancies, i.e. they die. There is no motive to expect biological systems to be governed by different rules than other dynamical systems. But by the same token, words can also serve to awaken the mind from its perceptual slumber, to make vivid and enchant the unfolding landscape. If my ecological lexicon is limited to terms like tree, river, and field, then I may walk along the mouth of the Halford River and see only tree, river, field. But as I realized from reading Robert Macfarlane's The Lost Words, with a more substantive, attentive vocabulary of that which is other than human, I may walk through just the same landscape and see oak, ash, birch, beech, copse, glade, grebe, goldfinch, poplar, yellowhammer, and yew, the same exterior terrain, but a greatly enriched perception of it. As psychologist James Gibson writes in his 1979 masterpiece, The Ecological Approach to Visual Perception, if we perceive the environment in terms of entities as defined by physics, then we are required to impose meaning on them in order to recover their vitality. But if what we perceive are earthborn entities at the outset, then their role in the web of meaning that weaves a human life is there to be discovered. This isn't that certain words are good and others are bad, but simply to recognize that just as the words I use to address a human person set a precedent for how they respond to me, so too can addressing a quivering deer with kindness or a gnarled oak with humility entail a surprisingly eloquent response. Poet and philosopher John O'Donoghue calls this a reverence of approach. I won't say more on this here, other than I recently wrote a piece with geographer Johnny Turnbull and environmental philosopher David Abram on what this might entail specifically in the context of maths, in particular the ways in which language mediates the relationship between the mathematical mind and the more than human world. Scientific models in ecology typically split spatial and temporal dimensions of reality into a two-dimensional cartographic map or three-dimensional Euclidean space on the one hand, and a separately evolving linear time on the other hand. However, this literature doesn't acknowledge that space and time, conceived of as such, cannot be empirically observed in isolation from each other. On the one hand, nowhere can I actually see a static triplet of perpendicular Cartesian axes extending infinitely into space, nor is any perceivable spatial object entirely without dynamism. On the other hand, that clock ticking on the wall, or well, in this case today, not ticking, wouldn't be able to tell me about this thing called the time if it didn't also change its spatial form by shifting its hands or electronic digits. Simply put, absolute and separate Euclidean space and linear time are not truths, fundamental inherent truths of the world, but just one model of reality. Now, as David Abram writes in The Spell of the Sensuous, this partitioning of time and space is a notion deeply ingrained to the extent that it shapes one's felt experience of the world, wherein Google Calendar schedules and ticking clocks become internalized to inform how I structure and perceive the events of my day to unfold. But this stands in contrast to the indistinction between space and time commonly experienced by many people. For example, the Dene of Dene Bekeya and the Hopi of Hopi Tutskwa don't have separate words for space and time in their languages. The Nunansiami of Nunavut have the word Uvatiaru, which can be translated both as long ago and in the future. Here's a quote from anthropologist Oki Hultkoms. The Lakota define the year as a circle around the border of the world. The circle is a symbol of both the earth with its encircling horizons and time. The changes of sunup and sundown around the horizon during the course of the year delineate the contours of time, time as a part of space. And if I direct my attention away from the clock ticking on the wall and ticking in my mind, and instead to my immediate sensory experience of the world, the feeling of breath in my body, the poplar boughs swaying in the wind, that silence from which a pigeon's hoot sounds and ceases, then the grip of linear time loosens, and I enter a very different world, more fluid than any concept of linearity or non-linearity, and where each building, cloud, human creature speak of their own distinct temporality. So if absolute and separable Euclidean space and linear time are indeed just notions, not even a human universal, but just one culturally specific model of reality, albeit reinforced by terraforming the external environment to reflect this conceptual ordering of the world, then why should one expect the rhythms of the landscape to fall in step with this particular schema? Again, just like putting on red-tinted glasses and seeing the world only through shades of red, what is missed by insisting on modeling ecological phenomena only through this one singular lens of time and space? More to the point, how might one approach this differently with mathematical models in ecology? Motivated by analogous questions in theoretical physics, mathematicians over the last 150 years have developed the subject of topology to create techniques for studying spatial form and temporal rhythm beyond the rigidities of Euclidean geometry, much more than just networks, with which the term topology has often become synonymous. This fundamental area of maths looks to study patterns of form and structure that are immanent to the entities being studied, rather than imposing transcendent order of time and space. Looks to understand the perspective of a situated rather than a placeless observer. Now, I began my doctorate hoping to use topological ideas to study patterns, spatial patterns in species distribution data from Borneo. However, I soon realized that much of the important detail had already been lost by the time the animals had been translated into numerical data points on my computer screen. And with some embarrassment, I realized that I had been more intent on seeing my favorite mathematical theories come to life in a case study, rather than prioritizing questions of ecological relevance. How might one bring topology to ecological questions without first throwing a grid over the world and insisting that the animate earth be riven into straight lines and decimal points? I was quite unaware at the time that topological ideas have become prevalent in the environmental humanities and social sciences. In their 2014 paper, Towards a Post-Mathematical Topology, geographers Lauren Martin and Anna Sakor trace the emergence of topological ideas from maths into human geography over the last 100 years. And they touch on its use by scholars such as Gilles Deleuze, Doreen Massey, Henri Lefebvre, Marilyn Strathern, and others. In situating technoscience, anthropologists Anne-Marie Moore and John Law use topological concepts to study the social relations and structures through which scientific knowledge spreads. And in Wildlife in the Anthropocene, Jamie Lorimer draws on topology to reframe theories of wildlife conservation and to investigate the dynamics of novel ecosystems. I'm now exploring how to bring topology in maths and in geography into dialogue with each other. I think that the mathematical field of topology, with its rich methods and concepts for studying spatial form and temporal rhythm, could offer a helpful elaboration of topological ideas in the social sciences. And conversely, I think that the lucid investigations into conceptual and experiential relations in disciplines like geography offer a really lively and well-developed foundation for mathematically modeling space and time differently in ecology. When I started my postdoctorate with Renew in February this year, I was actually quite nervous to be doing computational modeling again. I'd done a lot of coding during my PhD, and I found that the more time I spent in the world of numerical animal and pixelated landscape, the more I was drawn out of the rhythms of my body and the sensuous aliveness of the unfolding landscape. It was therefore strange for me to have found that not long after starting the postdoctorate, I was just delighting in translating ecological concepts into mathematical computer code. I think one reason for this shift is because of working with the people in Renew that I've been fortunate to think together with. I think another reason I trace back to last year in the autumn, when I had a chat with the wonderful Red River Métis scholar Zoe Toll from Amiskwachie in Canada. We spoke about story as methodology. That stories are not just nice to listen to, they can be great tools to think with. Now, this conversation must have been fermenting in my mind because a few months later it occurred to me, what if a mathematical model, like a story or a painting or a concept or a good Rumi poem, is almost a tool for thinking through ecological questions rather than a method for laying claim to irrefutable truth. Now, this perspective might be really obvious to some, but to a mathematically trained mind, it's an undoing of the knowledge hierarchy that places maths on a pedestal above other ways of knowing the world. And it's an invitation for the mathematician to move from being the one who knows to the one who listens. I'm not advocating for the rejection of existing mathematical models in ecology. They've been tremendously valuable. But rather, I'm advocating for opening to the possibility that other ways of using maths in environmental matters might be available. Without a precise understanding of how stories and concepts set a precedent for how things get quantified in ecology, just developing increasingly sophisticated mathematical models is like climbing ever higher up a ladder without questioning whether it was placed against an appropriate wall at the outset. This isn't just like an intellectual exercise, because any methodology that shapes how we study the natural world also shapes how we live within it. I think that maths at its heart need not be a reduction of the mystery, but a correspondence with it. And I think in this way, it can be dynamic and alive. It can be open and receptive, sending a question out into the more than human world and listening for the response. Thank you. And have some water, and then we can have questions. So I think it will alternate, one in person, one online, unless there are many more in the
Is there any in the room to kick it off?
David.
Yeah, you mentioned that when you started your PhD, you were to ask one particular question, but you actually found the data wasn't sufficient. Do you think it would have been possible at the time to collect data to ask what was missing in the data?
Just to quickly check, could the online audience hear that? Could someone just say in the Q&A if that was audible?
I've got a thumbs up. Yeah.
Cool. If I had had the time to collect the data, would it be sufficient? I think if I had a much richer set of data, that alone wouldn't be. I think perhaps if I'd actually taken the trouble to go and collect data, I think that might be different. The reason being, I think my limitation in that approach was not something external to me, just like there wasn't enough data, but actually the ways that I could conceive of using it, the ways in which I could understand what questions to ask. I think I hadn't arrived at a place where, even if there was more data, I could have done something much deeper. I think for me, I mean, it's different for everyone, but I think for me, a big part of this is actually like an internal process of reading the literature from other disciplines, speaking with people in different disciplines, and then that slowly changes the way that I would think about questions. And then, you know, maybe like not that much data is needed if I'm really clear on what I want to ask and how I want to approach it. Yeah, that's my guess from the experience of that.
Question online, if we think.
We'll do that and then we'll come to Rachel.
So this is from Marina Chen, who says, I work a lot in trauma-informed recovery. That's a huge, often missed or understood lens that impacts common perceptions, etc. Has there been any much incorporation of embodied, unresolved trauma in ethnomathematics, attunement, etc.?
There is a chapter by Helen Verron in a book called A World of Many Worlds. The chapter is titled Working Cosmologies Together While Keeping Them Separate. I think that's right. And she's somebody who had worked in ethnomathematics for a long time. And then she described this experience that in her own words stopped her in her tracks when she was trying to bring a kind of Euro-American curriculum together with there was a particular indigenous community in Australia, and then she realized that a genocide that happened on the land on which she was teaching about, I can't remember, 100 years prior perhaps, was actually affecting the way it was still present in the way that people approach numbers and that kind of thought. So I think there's a huge amount on embodied aspects of ethnomathematics. So I think that is one chapter. There's another chapter by the anthropologist Rick Pinkston and somebody else called Ethnomathematics in Practice. And they describe the Dene, like I guess the older name is the Navajo in the southwestern US. And like how to work with bodily intelligence in the way that's interwoven with cultural inheritance, to teach maths in a way that draws on their childhood experience. So I think Ethnomathematics in Practice, which is a book chapter by, it's either the title of the book or the name of the chapter, but it's the chapter by Rick Pinkston and somebody else. But yeah, there's loads. But for this person and also for anybody else, if you want to just email me anything that you want to ask after the talk, you're more than welcome to do so. Rachel.
I was wondering if you have a tool or method with your current work. You said that you're breaking away from a model that starting from the mathematical model and then going into the environmental landscape. So you're doing it the other way around and seeing what models come out of being in a place, embodied. Do you have a method for that, or is it listening and being in a place, and seeing what happens?
Two things come to mind. The first is that for that model, I owe a huge debt of gratitude to Kevin and to David, because their ecological concepts are so rich that it has simply been in conversation with them that I feel like I've tried to enter their conceptual space, and there's already so much there. So it wasn't difficult to try and bring mathematical ideas to that. But yeah, I think so. Recently, I read this book by psychologist James Gibson, The Ecological Approach to Visual Perception, and it just blew me away because through time in the landscape, he moves beyond concept. Well, concepts and percepts are not separate. I don't know if one's more fundamental than the other. They definitely influence each other. But through direct perception, he comes up with like a whole vocabulary of a kind of environmental geometry. And he's so lucid and precise. That book really blew me away. So I think I've just got to spend more time. But actually the attention is so important. And I think there's so much to be said about the art of attention. Like, just from my own experience, I know that like when I'm in a bit of a maths hole and I'm just trying to like write this line of code that's not working, the kind of embodied state of attention, it's like a fist that's trying to grasp. It doesn't have that light touch. And I think there's something about trying to keep in mind that sense of like staying back and like letting the world meet me halfway that feels really important in writing a mathematical model that isn't just imprinting itself on the world, but can listen to what's actually there. We've got one.
We've got nothing.
And then we'll come to Tim.
So this question is from Ruth Gripper from Renew, our impact officer. So she says, thanks, Siddharth. That was really interesting and mind expanding. As the creator of a mathematical model, you can think of it as a tool for thinking through questions and be cognizant of its limitations. But when you put something out into the world, you can't necessarily control how it gets used. So how do you handle the risk that external audiences might just want a model to tell them the answers or use it to suggest a degree of certainty that may not exist?
That's such a beautiful question. Thank you. think a huge part of it is how you write the paper that presents the model. So, like often when I read mathematical models in ecology, the language used, whether explicit or implicit, is kind of like, this model's the best, it does all these different things, and there's like a small section on limitations at the end of the paper. But really, I don't know how much is intentional and how much is unconscious, but there's really a kind of sense of wanting the reader to feel like this model captures the truth. And like, I think one thing that's important to recognize is that any paper is written by humans, and humans have lives to live and, you know, like need to earn a living, could possibly support a family, etc. And so there's obviously an incentive to presenting something that will get accepted by the community. I think, but I don't think it has to be in that way where, and I think maybe this is also a bit of the scientific culture, that it's kind of easier, or it feels easier to present something with a lot of confidence than to say, actually, like it doesn't do this, but more importantly, we tried to do this, but we couldn't figure out how to. But when I read a paper that is written like that, I feel like it's so much more honest and therefore rigorous. So I think one thing is about like the style of communication. I think another thing is like doing the internal work of becoming aware of what's really missing from a model. Because if you're not aware of it, it's really hard to know when it is and isn't appropriate. And I think if you pay attention to that work of what's missing, then actually just writing in a paper that presents the model, like in order to be accountable to the abstractions that we're using here, we're going to note that ecological science makes a lot of use of metaphor in writing models to conceptualize the kind of indeterminate landscapes into measurable scientific terms. And actually, the funny thing is, even though that might, it's not, I don't know, I don't see that in scientific papers, but actually I think that not only makes it more accountable, but also makes it more intelligible to people from other disciplines, because each discipline has its own language, its own set of terms. And I had a conversation on Tuesday with a group of anthropologists, and they were saying that what's so hard about communicating with a lot of scientists is that just like the language and the metaphors are taken for granted. And that's kind of doesn't really allow people in who aren't so familiar with those. So I think some kind of, yeah, what broadly just, I think an attention to language in communication. Yeah. Tim.
Sorry.
That's fine, Tim.
Got the whole of this story. But when I arrived, you were sharing a quote around paper on cheating.
Yeah.
And personally, I found the language in that quote to be very suggestive and leading you for a certain intuition or interpretation of what I understand is probably actually a mathematical result, subject to typical mathematical assumptions. So I was curious what your take is on the morality of that suggestive language, and also whether it's good practice from a mathematical perspective and also scientific perspective.
I read through that chapter really carefully, and from the best of, to the best of my memory, I can't remember them ever qualifying that this is just one particular way of doing it. There may be others. At least but it's been a while since I read it, but just from my memory of reading it, it sort of felt like presenting how things should be done. The piece that I wrote with Johnny Turnbull and David Abram was, I suppose, pardon me, inquiring into some of the more ethical dimensions of this. And I remember when I was doing my master's, I took this course in abstract algebra, and the textbook language, not like informal chat, like the textbook language was like X kills Y, F forces Z into the annihilator, lambda dominates tau, and like there was a lot more of that basically. And I remember once I just asked my lecturer, like, what's with the killing? And he was like, yeah, I remember when I started studying maths, I was surprised by that kind of language. And then the lecture went on. And I really don't want to like criticize anybody, because they're different, particularly for people whose first language isn't English, is not English. And so much of scientific mathematical communication is in English. It's just that much harder to be really attentive about language. But I think if ethics is not about right and wrong, good and bad, but if it's more about just an inquiry into how certain things affect the way we live in the world, then I think there are certain kinds of language that more engender certain experiences. Like I remember in my first year of my PhD, I was reading a book on stochastic modeling of biological processes. And the language was very much like, okay, these 70 people have been infected, therefore they go into the removes part of the model. And I remember reading it and just feeling really sad. And I was like, what's going on here? And I did notice that, like, and again, it's subtle because like so much of maths, whether it's language or concepts, happens through this process of reification, where like something is made more familiar and then starts to take on a kind of solidity. People in maths education like Anna Svard have written amazingly about that. And I did find that like in the maths, like doing my writing in the maths department and like continually certain language, when I would then like stand up and go and meet a friend for lunch, there would be some kind of cognitive dissonance where like I would find it difficult, it would take me like a bit of time to adjust to being open to things that were unexpected or strange. So I think ethical, moral questions are really important, not in the sense of like, you must do it this way, but just in the sense of like inquiring into how things shapes one experience. But there's so much amazing work written on that. My favorite is a paper by a professor of maths education with the philosophy of maths education, he's an emeritus professor at Exeter called Paul Ernest. And he wrote an essay called A Dialogue on the Deep Ethics of Maths. And I thought, wow, I've never read such an amazingly lucid articulation of ethical questions in maths. Yeah.
Apologies for people online, I think they missed that question, so
Okay.
in future we might just.
Yeah.
We do have a question from Lewis, so Lewis Elliott online. It's quite a long one, so I'll read the whole thing.
Go for it.
He says, I'm interested in what this new paradigm of model you're proposing in the conclusion could be. As a psychologist, I'm familiar with mathematical models being imperfect tools for studying human behaviour, highly irrational, emotionally governed. Or concepts like justice, fairness, and of course how these relate to nature and the natural world. But I still want to analyse relationships between these variables. That's the classical job of a mathematical model. Sure, I could select a different non-mathematical approach and use a social, scientific or historical lens to explore these relationships, but this seems to me not mathematical. So what could this new paradigm of mathematical model look like? P.S. The ecological approach to visual perception was on my undergrad reading list. So great to be reminded.
I have a suspicion that by being abreast of different perspectives and different insights, then one can use existing models to very different ends. So a big part of this, I think, is working with what's here, but just perhaps stepping beyond the usual confines of how things are done. So, for example, I gave a talk to a group of mathematicians in June on these ideas, and I remember one of them was working in optimization, and we had this chat afterwards, and I just so appreciated his engagement. He was like, "Oh, so like, what is this new paradigm? Like, am I still allowed to use optimization?" And ultimately, I kind of think it's for everyone to feel what's right for them. Like, the more I kind of inquire into this, the less I think that any of this is original. But actually, so many of these ideas have already been arrived at by so many people. But what is perhaps exciting and fresh, if anything, is the way they're brought together. So when I had that conversation with this guy about optimization, I recalled that one of the models I'm writing with Renew all centers around this particular optimization function. Now, optimization is something that has been like critiqued by science and technology scholars, science and technology studies scholars, various other people. But something about this optimization model that I'm writing now felt very different from what I was writing optimization methods a few years ago. And I think part of, I'm actually not sure how much of the change shows up in a kind of codified external way. Like, I feel like a big part of what makes this feel more ecological from the outset is firstly committing to starting with certain concepts in ecology rather than imposing certain concepts from mathematical ideas from physics. And I think another part is maybe just subtleties in how the model is communicated. And I suspect that once that more internal work starts to ferment and perhaps develop a bit, then perhaps actually quite different models may emerge, mathematical models. But I don't actually know. I feel like this is just like the start of a journey. So maybe I would say for now that don't stop using mathematical models. But maybe just being more aware of the context around them. Yeah. But maybe I can think a bit more about it. Sorry, I don't have a richer answer for you now. Yes.
So my name is Matt. I'm a professor of math in the United States. So thanks for your talk. It was really interesting. And so one thing that really resonated with me is this idea of language, especially in the classroom, right? I teach my students math. I often have these types of discussions about that in mathematics. But one thing that I wonder about from you is even more dramatically, I mean, there are vocabulary in math, which is problematic, right? Vocab, which is so permeated that it feels like we can't change it anymore. And I wonder, do you feel optimistic or pessimistic about the future of math in this way that, when I teach my students things, I can acknowledge, okay, like killing fields and so on. I mean, okay, but I mean, there are things like Hawaiian earrings or things which are known to be culturally insensitive. But we keep on using them because it's the language that is used by the community. I don't know, do you have any thoughts about what the future of math could look like or should look like in sort of this sense?
Could you say a little more about because I definitely have my own sense of certain kinds of language which maybe I take issue with, but I'd be curious to hear, could you say a bit more about the language that you find problematic? And if I hope nobody minds, I'm just going to have a bit of my sandwich because I'm so hungry.
So I guess I'll give you an example that I learned from my colleague. It's not my field, I should say. But in the field of arithmetic geometry, there's you already know the example I'm going to.
No, go for it.
In the field of arithmetic geometry, there's a branch called tropical geometry. And it's named tropical geometry because the people who discovered it were Brazilian. And we couldn't be bothered to learn the names of the mathematicians, so we just called it tropical. So things like this, right? I mean, there's a history, I think, of naming conventions in math which erase people, right, or erase or just unify cultures as just some abstraction. But we all know Hilbert's name, right? So things like this, I think, are things I think about and I talk about with my students a lot. Sort of, as you said, the human side of mathematics, right? It's people are the ones who name these things. We're the ones who continue this culture. So I guess things like this are kind of what I'm wondering.
I've done a quick summary in the chat, but I'm not sure it was very good.
Sorry. There's a paper by Ron Eglash called A Broken Metaphor. And he's the only person, it's the only piece I've come across which looks precisely into this question. And he was extremely articulate. And he was looking at, there's a metaphor in computing called the master-slave metaphor, where certain computational objects are called the master and then the slave, and then that also has all kinds of derivatives, stuff around it. And it was such an interesting paper to read. And he interviewed some engineers and mathematicians who had used that, and people from different ethnic and social backgrounds to just see how the feeling may have differed across them. And one person said something very interesting, which was, I think he was advocating, this was an engineer who had struggled with the use of that language, but also said, his take was, I don't think we should replace certain words with other words, because just a change in language won't change the things more deeply. I think that's one perspective. I think ultimately, like, I sometimes wonder if, like, in 50 years, if anybody is going to read what I'm doing, they might be like, oh my God, why did he use the term ecological? Like, didn't he know that was, an issue in these kinds of ways? And so I think certain things that are suitable in one time period may not be in another. But I also think that personally, I think that certain words could be replaced with others. Like I love the example that you give of tropical geometry. And I think an important way of doing it is to not impose the change, but to bring about the realization of why certain words may not be so appropriate. And then just through that, people may use them less. But yeah, I love your point. Thank you.
I've got another question from online. So this one's from Marina Cherm. She says, how are the worlds and insights of meditative practice and cultures and the nature of resonance or embodied attunement interacting with this work and your approach and your evolution of your thinking?
Could you read that again, just so I make sure I got it?
How are the worlds and insights of meditative practice and cultures and the nature of resonance or embodied attunement interacting with this work and your approach and the evolution of your thinking?
Wow. What an amazing question. Okay, there are two things that come to mind. One is I'm yet to find the way of presenting it explicitly such that it's kind of appropriately delivered in, well, at least appropriate how I feel in this kind of context. But I feel like an undercurrent in all of this work has been a daily meditation practice. And like my ancestors are from India. So for me, it's like in a Buddhist tradition. And there are so many layers to the way that this work is influenced by that. I think first and foremost, actually, like if through daily life we accrue ever more layers of habitual ways of thinking, then a meditation practice can, and obviously it's different for everyone, to different teachers teaching us very differently, but like a meditation practice can help peel things away and just kind of seeing things more clearly. So actually, so many of the shifts that happened during my PhD, like from maths, with ecology, with geography, with anthropology, like starting the day with a meditation practice, I felt like I was aware of I was slightly more aware of where things felt limited. And I felt like I just had some kind of spaciousness to see that things that I had just taken as a given might just be one way of doing things and there could be another way of doing things. So I think in terms of just helping to like metabolize experience and direct the course of thought in a way that is in service to something you really care about, I found meditation very helpful for that. A second thing is there's a First Nations scholar, Zoe Toz, and we are, so she is coming from like a Red River Métis perspective of embodied attunement to the landscape, moved from a Buddhist perspective. And we're in the coming year going to bring our perspectives into dialogue with each other to kind of think what a sort of indigenous approach to mathematical models in ecology could look like. And I think many people have written about that before, but again, like, reading an academic paper is one thing, but like letting it percolate into your mind and affect how you are in the world is another. And I think that quality of embodied attunement, at least for me, is a kind of undercurrent to all of this, because without attending to something, like where there is attention, there's the possibility of love, and where there's love, there's the possibility of care and doing work in service of that. And I think if I didn't attend to the natural world, then none of this work would come about. So yes, to embody the human. Yes.
So I've kind of got two sides. I guess one's maybe a checking of my assumptions and my interpretation. The other part is more of a question. And the checking of the assumption is by being with and in place, holding that attention and that perception towards place, perhaps with that intention you go into that place with. I would imagine that attention and intention may then morph through relationship with place. So that which you went into that place with an inquiry of may then change. So there's part of me holding that as a, on the other side of it, the question. So I'm working, for example, in renewable energy, and these models, these mathematical models go out and do work in the world. And so how do we as a society perhaps recognize that we're still trying to maintain, maybe that's a question whether we should be maintaining these lifestyles through acts of using these models in the world, versus the requirement, or maybe is it ethically more appropriate that people actually are embodied in place to work with that place to draw utility, or the utility at least for our survival, continuation from it.
Okay, so to reiterate the question for the online audience, but also just to check that I got you. There's a thought which is regarding that you may have a particular intention about how to be in a place, but then with that place, those intentions and attentions may change.